Welcome to Pareto Code. Hello and welcome back to Pareto Code. In our last video, we wrote our very first Java program. We learned how to store information in variables and print it to the console. It was a huge first step, but our program has a limitation. It does the exact same thing every single time it runs. It's static. What if we want our program to be more dynamic? What if we want it to react to the user, to make decisions based on what they type? Today, we are going to make our programs smart. We will learn how to listen for user input and how to use that input to make decisions with if-else statements. By the end of this video, you'll build this, a simple program that can have a real conversation with the user. Let's get started. The first step in making our program interactive is teaching it how to listen. Right now, our program can only talk, using system.out.println. To listen for keyboard input, we need a special tool from Java's built-in library. This tool is called the scanner. Using the scanner is a simple three-step process. First, we need to tell our program that we want to use it. At the very top of our file, before anything else, we write import java.util.scanner semicolon. Think of this like telling our program to grab the scanner tool from Java's main toolbox. Second, inside our main method, we need to create an instance of the scanner. We write this line: scanner input reader equals new scanner open parenthesis system in close parenthesis. This might look a little complicated, but let's break it down. We're creating a new scanner and telling it to read from system.in, which is the standard input stream, basically the keyboard. We're giving our new scanner the name input reader so we can refer to it later. The third and final step is to actually use it. Let's first ask the user a question, like, please enter your name. Now, on the next line, we can capture their answer. We'll declare a string variable and use our scanner's next line method, like this. String username equals input reader next line. This line tells the program to pause and wait. Whatever the user types before they hit the enter key will be captured and stored in our username variable. Let's prove it works. We can now say hello to that specific user. System out print line. Hello comma space plus username plus space exclamation mark. When we run it, the program asks for my name. Perfect. Our program can now listen. Okay, so now our program can listen. But what's the point of listening if we don't do anything with the information? This is where we need to make decisions. In programming, the most fundamental way to make a decision is with an if statement. Think of an if statement as a fork in the road. It checks if a certain condition is true. If it is, and only if it is, we will execute a specific block of code. The condition for an if statement goes inside parentheses. To compare strings in Java, we use the dot equals method. But what happens if the condition is false? Right now, nothing. This is where the else keyword comes in. Else is the other path at the fork in the road. It gives the program an alternative set of instructions to run if the if condition is false. This is great for two options, but what if you have 3 or 4 or more? For that, we can chain these statements together with else if. If checks the first condition. If it's false, else if checks a second condition. If that's also false, it can fall through to another else if, and finally to a catch-all else block at the very end. The program will only ever run one of these blocks. Let's put everything we've learned together into a single practical program. We'll build an age checker that tells a user if they are a child, a teenager, or an adult. First, the setup. We import our scanner and create a new scanner object. Then we'll prompt the user, "Please enter your age." Now we'll read their input using next line, but there's a small catch, a critical one. The next line method always gives us a string, which is just text. We can't do math or number comparisons on text. We need to convert that string, like 25, into an actual integer number, 25. We do this with a handy Java function called integer.parseInt. So we write int age equals integer.parseInteger input age semicolon. This is a hugely important step and a common place where beginners get stuck. Remember to convert your input if you need a number. Now that we have the age as a proper number, we can use our if-else logic. First, let's check if the person is an adult. If age greater than or equal to 18, we'll print "You are an adult." If they're not 18 or older, we'll check if they're a teenager. Else, if age is greater than or equal to 13, we'll print "You are a teenager." And finally, if neither of those conditions were true, our catch-all else block will handle everyone else. Else, he's system.out. You are a child. Let's run it. If I type 25, it says I'm an adult. Correct. If I run it again and type 16, it says I'm a teenager. And if I type 8, it says I'm a child. It works perfectly. And there you have it. In this video, we gave our program two superpowers: the ability to listen to user input with the scanner class, and the ability to make decisions with if-else statements. These two concepts are the absolute foundation of creating interactive and intelligent applications. Now it's your turn to practice. Your challenge is to build a simple password checker. Make a program that asks the user for a password. Create a secret password inside your code and use an if statement to check if the user's input equals the secret. If it does, print access granted. Otherwise, print access denied. Thank you for watching. If you found this helpful, please hit the like button, subscribe for more videos, and let me know in the comments how you did with the challenge. Happy coding, and I'll see you in the next one.